Hello there again, Engineering Science, Mr. Young here, back again with another video on analog electronics, this time looking at combined circuits. And we shall have a look at, always as before, looking at the learning intentions, being able to combine parallel and series resistors in a circuit, and you should have been able to work through the series resistors worksheet and the parallel resistors worksheet and get the answers for those, hopefully by using the different equations, either for parallel using the 1 over R1 plus 1 over R2 etc, or the R1 times R2 over R1 plus R2. Okay, for parallel, and obviously series is just adding resistors together. Right, so there we are. As before, we've got resistance is always measured in ohms, and we've got their series one here on the left hand side, and on the right hand side we've got the ones in parallel, so as they're above each other, and this one is in a line. Okay, so what happens then? It's in a combination. Well, the combination means parallel and series in one go, as you can see here. The lower two, there's 25 ohm and 19 ohm, are in parallel to each other. However, these two are also in series with this one, 36 ohm resistor. Let's just try and take this a step at a time here. In most cases, or nearly all the cases, you will actually solve the parallel branch first, which is this one. This time I'm using a wee pen rather than the wee light up pen. I don't know how well that's been shown up in the videos, or if I'm all over the place waving it about. Okay, so we're going to deal with the parallel branch first. So only two resistors, so I'm going to use my RT equals R1 times R2 divided by R1 plus R2. Okay, there we are. So R1 times R2, so 25 times 19 divided by 25 plus 19. Okay, again, work out top and bottom separately. So 25 times 19, get that answer, 475 in this case, and find that bottom answer as well, which is 44. Find them out separately, and then obviously what we're going to do is 475 divided by 44 gives us our parallel branch total resistance. Now that's just the total resistance for this bit, just for that sort of those two resistors. That's not us done, not quite yet. We'll still have to deal with this one at the top here. Okay, so what are the rules? Well, remember that the total resistance in a parallel branch, these two, always has to be smaller than the smallest resistor. So the smallest resistor here is 19 ohms. This is 10.79. I might have rounded this up just to make it a wee bit easier to see. So a nice even number, 10.79. It is smaller than this, so I'm quite happy with that. So what does that look like? Well, now what it looks like is this. We've got our 10.79 resistance. I'm just putting that resistor in there because that's the equivalent resistance of these two in the parallel branch that we've just worked out, and we've still got our 36 ohm resistor above. Right, so now if I've shown this like this, it now becomes a series circuit. So now we can use our series equation, which is just this 10.79 plus 36. Okay, RT equals R1 plus R2, right, as before. So as I've said, 10.79 plus the 36 is 46.79, right, just adding those together, and again in ohms. Always make sure you put your ohms at the end, right, and that's what it is. That's as simple as that. And like I say, in most cases you'll deal with the parallel branch first. There will be some exceptions. I will show you just one of them. One of them might be an exception like this. We have two resistors, top and bottom, in the branch here, the top branch and the bottom branch here. What we'll need to do is add the top ones and the bottom ones together separately, and then we'll need to do our other equation. So what do I mean by that? So if we look at the top branch here, R1 plus R2, so 20 plus 10 is equal to 30, because R1 and R2, remember, are in series because they're linking up with each other. R3 and R4 are in series because they're linking up with each other. So when we come to do 3 and 4, it's 5 plus 2 is 7. Okay, so that's what we've got. So now what we've got is this. So we've got a 30 ohm resistor at the top, and we've got a 7 ohm resistor at the bottom. Okay, so now that's in parallel. So we're going to use our parallel equation, the one we used before. Okay, so let's have a look at that one now. So again, R1 times R2 over R1 plus R2. And again, work these top and bottom bits out separately. So 30 times 7, 210, divided by that 30 plus 7, which is 37. So you should have 5.67. Do I need to remind you what the golden rule is again when you're looking at total resistance? Let's have a look at it. We've just dealt with a parallel branch, remember. So we're looking at this number 5.67. Is it smaller than the smallest resistor? Our smallest resistor now is 7. Is it smaller than that? Yes, it is. So chances are you've done that right. Okay? If it was a bigger number than 7, then you have to maybe think about what you've done and go back and check some of your working. Right? So just remember that. Most of the times you'll be dealing with a parallel branch first and then doing it in series. Just depends how it's been laid out. Have a look how it's laid out in the circuit. Okay? When you look at a circuit, if it's got the one that we've seen before and it's got the parallel bit first or parallel bit in there and somewhere in the circuit, deal with that first. Okay? So just so we recap, when you're using two parallel resistors, use that R1 times R2 divided by R1 plus R2. When you're working on series resistance, you're looking at R1 plus R2 plus R3, etc. Okay? In most cases, you'll deal with that parallel branch first, so look for it in the questions. And if you're unsure, just check. There are exceptions that I've shown before. Just depends on the layout of the resistance or resistors in the circuit. And remember, the total resistance is always smaller than the smallest resistor. So again, when you've got that final answer, just check it, make sure you've done it right. Okay, so that's just some of the wee kind of hints and tips for this combination of resistors that you might get. And it's useful because it's getting a bit more tricky now, and that's useful because some of the circuits you might have to deal with are a bit more complicated as they go on in this topic. Also, being able to use more than one resistor is a good way of leading into another type of resistance that we'll see shortly, which is called voltage dividers, and that helps have a bit more control in the circuit. And that's what it's about, is having a bit more control about being able to use certain resistors to control the circuit better, and then control the output a little bit better as well. So it is leading towards voltage dividers, having more control and looking at more complex circuits. So this is a useful lead in. So if you're following along and doing alright, then good, well done. Alright, as always, thanks for watching, and please stay safe.